Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Abbas bin Muhammad Ismail, number matric CE200132. Today I will explain in detail about project 2 part A. As you can see here, this is our table, and my group increment is 2.5, and at the right side is my new data. And how I can obtain this data is with as you can see here, the 2S, 2P, PM, SM times with the 2.5% increment. So we get 45 times with 2.5, we get 112.5. And the rest of the data is times with the 2.5 increment. Alright, now we go to the part A. As you can see here, this is the blank JMAC. So we go to the project untitled, we go to the geometry editor, we create the geometry, and it will become like this, as you can see here. Alright, and then the next step is we need to create the 2D sketch. After we click it, we become like this, and we become like this. So we need to make a circle, and then for the example, like we click here and we just drag it out and we put the data. Alright, for the data of the rotor, first we need to make the rotor first. So this is our data, our calculation, to be precise. This is shaft radius, which is 12.5. The outer radius rotor minus with permanent magnet, 60 minus with 8.75, which is we get 51.25. So the shaft radius, as you can see here, this is 12.5, and this is the outer part here is 51.25, and the outer radius stator, which is the upper here, is 60. We refer the 61 from the table that I calculate just now. So first we just create a three circle, the 12.5, 51.25, and 60. And then for the first half of the circle, we trim the below part, and we make a line. As you can see here, this have the line. Okay, and then we trim it, and this part, the upper part of the 60 with and the 51.25, we delete it. As you can see here, we get like a tunnel here, and then how we delete it, we make it a 12.5 because we got the calculation is 12.5 for the tunnel here. And then we just create a region here, we delete it in the inside part, which is here, we trim it here, so we get like a L shape, like an reverse L shape. So we create a region, and we mirror it, and we merge it, we mirror it to this line, and we get like a half hemisphere, and we merge it in this line, so we get the full circle here. Alright, that's for the rotor part. And then for the permanent magnet part, it's more easier. We can see the calculation first. Alright, this is our permanent magnet in outer radius rotor, which is 60. The outer radius rotor minus with permanent magnet, we got 60 minus with 8.75, we got 51.25. And basically is here is 51.25. Yeah, 51.25, and this is 60. Is at the end of it is 60. See, 60, and this is 61.25. So we create a circle of it, and we trim. As you can see here, we trim the upper part of it, of the 60 degree, and then we create a region, and the difference between the upper part and the lower part is the same, which is 12.5. So and here you can see the line. So we create a region here, we merge it with the bottom, and then we do the y-axis reference, so we get the mirroring to the left side. So we get two perfect permanent magnet, as you can see here. And then next step, you can see here. Alright, I'm sorry. Alright, as you can see, the next step is the stator. The stator part is like reverse L shape, like here. It's like here, L. Alright, first we go to the calculation first. To the stator part. Alright, this is our stator, and the outer radius rotor is plus air gap is 60 plus 1.25, so we get 61.25. The outer radius stator minus with shaft radius, we got 112.5, minus with 12.5, we get 100, and the outer radius stator is 112.5. So basically this is 112.5, this is 100, and this is 61.25. As you can see here, they have air gap here. Alright, to make it is have the simple principle with the permanent magnet, with the rotor. So basically we make a line and we make a circle, and the upper part of the 61.25 and 100 we delete it up, and we just left it like a shape here. As you can see, as you can see, we have create a line here, so we can mirror it. So, and then before that, we make a region first, the L shape. We create a region, and then we mirror it to the left side, and then we mirror it to the downside that here. So we get the full circle. And then we make an armature coil. As you can see here, they have a 4 part. Why it not combine? Because we don't merge it, so we can get a 4 armature coil. And for the calculation here, outer radius rotor plus air gap, we get 60 plus 1.25, which is 61.25. And outer radius stator minus with shaft radius, we get 112.5, and minus 12.5, we get 100. So basically, the lower part is 61.25, the upper part is 100. So we create like the stator, like the permanent, like the rotor. It's almost the same technique to do it. So we create a 2 big circle, and then we create a line, so we can and then we delete the lower part for the big circle, and then we create a region here, and we we mirror it, and then we create the mirroring, but this is a reference with the x-axis. Yes, the x-axis, if I'm not mistaken. So we become to the lower part here, and then we mirror it to the right side, so we get the 4 part. And then we just save it, and we save the project, and we get the result like this. We get the result like this, and that's for the part A. Alright, as you can see here, this is our part 2, and as you refer at the part 1, we only do the geometry editor for the 2D sketch, and this is the 2D model. And what's the content for the part 2 is we need to put the condition into the 2D model. Alright, and I will show you right now. As you can see here, this is our 2D model, and first how we want to assemble it, we just right click here, new study, and we click the magnetic transient analysis, and it will show like here, study magnetic 2D transient. And this part, after you reach this part, you need to put the parts, which is, as you can see here, I already put the rotor 35H to 10, stator to 35H to 10, and you can refer it to on the question stated here. Wait a minute. Here, the material one. the 35H210, 35H210, conductor copper, and so on. And how to find it? First, we need to go to the material toolbox and we just type the thing, which is 35H 210 right here, and we just track the 35H 210 at the stator and the rotor one. And then we go to the this is my list for the part 2, because it's kind of complicated for me to just to remember how the step is, so I just list it down. Okay, this part I already talked about. And then we go to the armature coil, which is the conductor copper. And then we go to conductor copper. Conductor, we choose the copper and we just drag it down to the every armature copper, like here. 1, 2, 3, 4. 1, 2, 3, 4. Okay, after that we need to do the permanent magnet one. Permanent magnet one is kind of complicated. So after we put the permanent magnetic here, we double click it, and we need to set the magnetization pattern is radial pattern, and number of pole is 2 at the both side. And I don't want okay, it's okay. And then we just set it to both of them. Sorry. Alright, and then we set it to, and we just as I just show you just now, we choose the radial pattern and number of pole 2. And then we go to the study magnetic, and then we add the circuit. The circuit we can refer to the question. This is the circuit that we need to implement. And then we go to this part, and then we can show it with magnetic. We go to the study magnetic to the transient, right click, which edit circuit, and this is the result. After that, we just close it, and then we go to the material part. Alright, and this is double click the coil, and we put the 1.25. 1.25, the value is I get from the table earlier that I show you before the part 1 that I've shown you. Alright, next part, we do the condition part at the toolbox, and the rotor is the rotation or motion. Rotation, motion. Rotation is the condition, I think. We just choose the rotation. This is the part. As you can see here, the motion, the rotation. We choose it here, and you can see here, we just pick all the part that need to rotate. As you can see here, we just choose with the permanent magnet and the rotor, and we put the value of 3000, because I get it from the increment 2.5 increment at the table that I shown you earlier. So I can show you the rotation here is 3000. For the speed is 3000. And okay, cancel. And then we need to put the nodal force. Nodal force, stop, and drag to motor, rotor, and permanent magnet, and click OK. And then we go to the nodal force, stop. Nodal force. This one. You can see here, this is the part, nodal force, stop. And we choose the nodal force and drag the rotor and permanent magnet, and we click OK. As you can see here, I already stated it. And then we go to the FEM coil at the toolbox. Okay, I don't want to. It's okay with which one. And FEM1, as you can see here, we have two parts because we have four armature coil, and this one FEM coil, and then we need to drag to the armature coil at the right above, and we need to set it downward, and then we add the coil set 2 at the right left, and we set it upward. As you can see here, the right one is upward, we choose it downward. The right side upward, we choose it downward, the direction of the coil. And the coil set 2 is the right side downward, we choose it upward. Okay, and then it's the same with the FEM coil at the left side. If the left up, you choose the direction per coil is downward, and then the coil set 2, we choose the left side, bottom is upward, as you can say here. And then we do the same with the coil at the right side. And then we go to the study magnetic properties, and this is the kind of tricky part. We go to the properties, and we just set the number of steps 37, and end of time is 0.05, division is 25, and the step length is 25. The number you can refer to at the question, this part 37, 0.05, 36 to 25, and then this is the type, and then this is the easier part. And then we go to the mesh, we go to the property, and then we go to property and we click the slide mesh. We go to the mesh, we go this, we go to the property, we go to we choose the slide mesh, and we just put it okay. And then we generate, if I'm not mistaken, after we should click the mesh, slide mesh, and then you generate, and then after we generate, we go to the study magnetic part here, and we just run the active case. Yeah, we click it. We run the active case, and we show the graph. Okay, I will show you the graph. Okay, it's not here, it's below. So here, graph FEM coil induction. Okay, this is the graph that I get from my 2D model part 2, and that's all from me. And I will give to myself at part B. Alright, after we finish for the part 2, for the 2D, we create the 3D part, which is the part 3. Okay, I will explain in detail for the part 3. As you can see here, after we finish, we just right click here, we extend the model to 3D. And after we extend to the model to the 3D, we got the solid model here, as you can see here. And then the first thing that I will do is, we go to the condition, we go to the symmetry boundary, and we just drag it to the all of the component that we create, and we click it all. We click the stator, permanent magnet, armature coil, rotor, and we make it at the both side, which is the back and the front. So we click it here, as you can see. And then after we click it there, we make sure our report don't have an error. And then we go to the mesh, and we go to select the property. We go to here, and then we follow the extruded mesh 1.05 and the slight division. We just follow it all. Like here, we set the circumferential division automatically. And before that, I select with the stack control based on motion condition. But when I generate the mesh, it untick for me. I don't know why, but yeah. But this is the first that I do. I click it both it. I'm okay with. I press OK, and then we create the face. As you can see, we add size control, and we choose the part face. As you can see here, we have two part face, the rotor one and the stator one. The rotor one and the stator one. And then we choose, and then we create size control for the face. And the face is the outer line here. Yeah. And we need just click at the stator, the permanent magnet, armature coil, and we get this line. And then after that, we create we add the rotational periodic mesh, and we choose the automatic part. So we get the automatic part, and we change the title to the automatic. After that, we can generate the mesh. After we generate the mesh, we see the result. We see the result if have to see if they have an error. If we don't have an error, we go to the study magnetic here. We right click, we go to the properties, we change this tree, which is number of step 37, and time 0.05, and division 36, and press OK. And then we just run active case, and we get the answer. The run active case take quite a bit of time. For me, I get for like 30 to 40 minutes of the rendering. And then we go to the graph, and I want to show you the FEM coil inductance. So this is my FEM coil inductance for this circuit. And that's all for the part 3. Thank you very much.